All right, so starting on unit 3, creating and solving formulas in geometric series. I'm going to try to just do half of it. If we have more time, we'll get into that as well. Um, as always, guys, if you guys are having trouble with the mastery test, do the practice. Do the practice like a million times so you get used to it. The beauty of the practice, let me just show you one for example. Let's say I have no idea how to write this and I just submit my answer and it's like, whoa, you didn't even do anything. And I'm just like, I don't know. Maybe my answer's this. And it's gonna say, hey, you're wrong. Try again. So you can retry these a bunch of times. This is the time for you guys to just mess up and just try to understand what's going on. And they'll tell you how to do it. So read this. Don't just be like, oh, I got it wrong. Let me go to the next one. Read this and understand what's going on. If you're still having trouble with the practice, make an appointment with me. We can go through questions together. All right. So the practice, again, this doesn't count towards your grade. It gives you a grade, but it doesn't count. All right. So meanwhile, let's get on to Unit 3 tutorial. Let's see what we're doing here. So I'm going to try to just do 20 slides of unit of this module. We'll finish the rest off on Thursday. If we have time, we'll talk for a bit. All right, so what's our objective here? So objective in this lesson, I don't know what's up with Edmentum. They keep giving these very broad objectives. We're going to learn how to create and solve formulas for geometric series. So a geometric series is whenever something keeps getting multiplied. So for example, an example of a geometric series would be like if you got a penny every day, or if you start off with a penny, I once forgot to. That is a random fact. I don't even know what was just said right now in the chat. Anyway, so let's say you were given a penny and every day it doubled. So first day you have 1 penny, second day you have 2, next day you have 4, next day after that you have 8. This is a geometric series because it's being multiplied. So that's what a geometric series is. It's a series that keeps getting multiplied. What is that? The Dipper hat? It is. Oh, that's Matthew. Matthew turned on his camera. I was like, oh, you did. You know, we're not doing that this time, Matthew. But thank you for doing that. Um, so a geometric series just means it keeps getting multiplied by a certain number. So that's what geometric means. Um, I'm not sure if we're going to cover arithmetic series. I can't even spell it right now. That's supposed to be an H. All right. And this just means you're always adding something. So an arithmetic series, when you're always adding the same number, that's usually like a linear function because it has the same rise over run. You're always adding the same number and going over, adding the same number, going over. Geometric is you're multiplying the same number over and over and over again. All right, so let's get into geometric series. So in this geometric series, there's this rule. This looks a little complicated, but all it means is A1. A1 is how you start off. A of n is what we're going to do. So, for example, if I want to find the fifth term in a series, I'm trying to say, what is my A of 5? So n just means number. What number are we on? So this rule is what it's saying is we're going to take n of 1. That means the term from before. So for example, if I have this series right here, this isn't a, well, yeah, I'll do the geometric series. I keep doubling, right? So this is going to be called my 1, 2, 3, 4. This is going to be called my A of 4. So my A sub n is going to be 8. If I say, oh, wait, my ace of 4 is 8. My n minus 3, if I'm talking about ace of 4, would be ace of 3. Ace of 3 would be 4. So this just means, so A sub, and it's called sub, as in subscript. That's why they say sub, because I don't want to go A subscript 4. I just say A sub 4. So when I'm doing this, I'm going to say the term from before times 6. So that means we're always going to be multiplying by 6. So if I want to find A sub 2, my formula is 6 times whatever A sub 2 is minus 1. So if I'm finding A sub 2, I'm really finding out what is 6 times A 2 minus 1, A sub 1, which is 2. So my second term is 12. It seems like a lot of work, but it's honestly not that bad. I'll show you guys why it sounds more complicated than it is. All right, so my first term is 2, and then I have to multiply it by 6, 12. And I have to multiply that by 6, 72. Multiply that by 6. I know what 12 times 6 is, but I don't know what 72 times 6 is. 432. So looking at that, I can automatically say that my answer is this one. Another rule is, since we keep multiplying by 6, another rule we can say is A sub n is equal to this. And I'll show you why. What's happening here is, how many times did we multiply by 6? So if we're doing A sub 2, we've done it one time, right? So we started off at 2. This is where we start off at. This is our A sub 1. This is what's known as our common ratio. I recommend taking notes on this, guys, because I might use these words later. So this is our common ratio, and then it's n minus 1. Well, if we're doing A sub 2, it's 2 times 6 to the first power. So, in other words, saying something like A sub n is equal to 6 A sub n minus 1, this is the exact same thing as saying common ratio. I'm going to put this as C for our common ratio times our common difference to the n minus 1 power. So in this case, our common difference or common ratio was 6. I am recording, so don't worry about that. I do recommend taking notes, though, because it does help out. All right, so next thing here is, so that's basically it. So that's how we figured those out. Does everyone understand how this is the same thing? Everybody good? Anybody need me to explain it? Nelson rejoining again? All right. Yeah, I know that happens. That's also why I try to record all the lessons. So that's what's happening here, is they're saying that we start off. What do we start off with? We start off with 2. and then we get 6 from the term before. So it's the term before. So in other words, we keep multiplying by 6. So that's why it's called explicit, meaning that this works no matter what it is. It helps because the explicit function, we don't care about what happened before. So this explicit equation, we don't care about what happened before. This rule right here, this recursive formula, when we're doing a recursive formula, we care about what happened before. All right, so let's go to our next one. And again, watch these introductory videos. They're really useful. Well, apparently they're talking throughout this whole thing. Okay, so they're talking about car loans. So recursive geometric formulas are a good way to know about car loans because you get charged interest. So you want to know how much money you're paying over time because that interest keeps piling up and piling up and piling up. And the first time you buy a car, I'm not sure if a lot of you know this, but most of your payment is going towards interest. A little bit goes towards what's known as your principal, which is what you pay down. So if you guys are ever interested in understanding why new cars cost so much, it's literally because people don't buy them cash, they finance them, and financing the car is where a lot of the money goes away. So let's talk about creating a geometric formula. So a geometric series, again, you guys can always read this. A series is adding them all up together. So we're going to keep adding those up. A common ratio, we talked about this. We're going to be talking about what gets multiplied every single time. So if we're always multiplying by 2, our common ratio is 2. All right. So other than that, sequences, we talked about sequences. If you want to see sequences, this is going to be very good for you guys. I recommend printing this out, to be honest, for this module, because there's so much words that you're going to need. So, keynote to everyone, on slide 8, print out that sheet. This is really good. I wish this would be provided in the units. If you guys ever do the packets, Algebra 2 on the packets is really hard because they never give you something like this. All right, so here's our formula for a geometric sequence. A sequence, again, that's just the one with the commas. A series is adding. So sequence, commas. A series is a sum. It's all of them added up together. So sequences are just a list, and the series is them added all up together. All right, so if we're looking at this rule where we're always multiplying by -2, notice how they keep alternating. It's a positive, then a negative, a positive, then a negative, because we're multiplying by a negative. So notice that because the negative common ratio, the terms in the sequence alternate from negative to positive. That's because a negative times a negative is a positive, but a positive times a negative is a negative. So they're going to keep flip-flopping. All right, so the next one here, let me do this. So if we look here, this is always being multiplied by 3. They're not flip-flopping. They're always being multiplied by 3. So we're going to look to see what we're always multiplying by. So our a sub 1, what's our first term? Our first term is -3. So the way you write an explicit function, you always do your starting term as a sub 1, and then you're going to do your common ratio. I'm going to call it R. I think that's what that one sheet called it. Yep, they call it R, common ratio. So I'm going to try to use this formula a lot. That way you guys can understand it. So R, and then we want to do the next thing, which is n minus 1. So whatever the number was before it. So what's our R? We're always multiplying this by 3. Always multiply by 3. So our 3 goes in the parentheses, and then we have n minus 1. So right off the back, I see that my answer should be this one. I start off with -3 and I keep going. So let's look at the next one. All right, so what's going on here? So I'm going to start off, my a sub 1 is 3. Next, wait a minute, I'm not multiplying. I'm multiplying by like a fraction or something. What happened here? The way you find your common ratio, guys, is you always do new divided by old. This is the same way you do scale factor in geometry. It's always new divided by the old one. All right, so let me see this. So I get 1.5 divided by 3. 0.5. Well, none of these are 0.5. But another way of saying 0.5 is 1/2. It's obviously the only other one that could have been an option was this one because our a sub 1 is 3, but we're not multiplying by 3. We're multiplying by 1/2. We're cutting it in half. So if we're always cutting it in half, this has to be my geometric sequence. So keep in mind, we're looking for drag the tiles, blah, 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 used for the explicit formula. So if you guys have this printed down, our explicit formula is right here for a geometric series. All right, this next one, what's my a sub 1? My a sub 1 is -3. So what I'm going to do, I realize it sounds like I'm saying ace of 1. I'm not saying that. I'm saying a sub 1. My a sub 1 is -3. So the only one that has a -3 besides the one I already used was this. So it's probably going to be this. Let's double check. It keeps alternating. So that's how come the negative is the one in the parentheses. Oh, shoot. Start off with -3. All right. So we start off with -3, and I keep multiplying by -3. So this answer is meant to throw you off from this one or this one. All right. So the next one that we have, what's my a sub 1? 227. So our only viable options are either this one or this one. And it looks like I keep dividing by 3. So if I keep dividing by 3, I'm doing 1/3. But is it -1/3 that I keep multiplying by? Or is it +1/3? Well, the signs are staying the same. They're not going back and forth from negative and positive, so it can't be the negative one. Is this making sense, guys? I know I might be going a little fast, a little slow for you guys. Does the pace kind of feel good? Makes sense. Cool. All right, so our next one. So again, sequence. A sequence goes on forever. A infinite series. So I talked about infinite series. We just keep adding them all together. Infinite means we don't stop adding. We keep going on forever, 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 forever. Normally, An infinite series will add up to infinity because it keeps going on forever. But let's say we start adding up to fractions. Eventually, you get to fractions so small they're basically zero. We'll talk about those later. But for right now, when you hear this word infinite series, think infinity. It goes on forever. When you're thinking finite, it stops somewhere. It has a specific term and it stops. So we're going to start seeing the formulas. So this formula is sigma is the capital letter in Greek for S. So that's why we use it for adding this up. So what's happening here is this says we're going to start off at 1 and we're going to keep adding until we get to 10 terms. So this is always going to be our starting point. And this is going to be where we stop. Stop adding. This is what makes it finite. Sometimes if you see it like this, with an infinity on the top, that means it's an infinite series. It keeps going on forever. So the next thing we're going to do here is, let's say we're doing this one, pi times I squared. That means for the first one, we're going to do 1 squared times pi. For the second term, we're going to do 2 squared times pi. For the third term, we're going to do 3 squared times pi, and so on and so on and so on until we get to 50 squared times pi. That's all we're doing when we're doing these, when we're using sigma to find our series. So let's get on to another slide. All right, so we're going to do a finite series all the way until they say k. K is the term that we're on. So they're not using n. N in this case is the one that we end on. So like I said, use this sheet. It's really going to help you out in understanding these. Again, you guys can always print out anything that you want or write down anything that you want. So this is probably a good sheet to write down for notes. All right, so here's what we're doing here. A to the k. What's k? Well, whatever we are in the series. If you guys ever, the equation looked like a pirate laughing. What? How did it? Oh, because it has the eyes and I guess. Oh, R. Oh, I get it. Because it's R. Okay. Choo. Anyways. All right. So what we're doing here is what are we on? And n is the number of terms. Oh, that's a better way to describe it. A sub n is the last term because n is the number of terms. That makes more sense than what I was doing. And k is the term you're on in the sequence. No, it's okay, Nelson. It just reminds me of when I used to have you in class. Good times. Well, I still have you in class. You just talk less here. You talk in the chat more. All right. So that's how we're going to be doing this. We're going to keep going on forever until we finally get to that last term. All right. So let's see how we do it here. So if we want to see this, we're going to use this formula. We're going to keep going on forever and keep doing it. This takes a while, so they're going to show us an equation that actually goes through how to do this, instead of having to do it every single time over and over and over and over again. Notice how they start at 0 for this one, so you always want to pay attention to this. So if it's 0 to 4, that means there should be 5 terms. 1, 2, 3, 4, 5. Because we're starting 1, 2, 3, 4, but we're also including 0. All right, so let's see what equation they end up giving us here. And of course, they just fill in the answers. So they're asking us, what are we going to do here? Well, we know that this is our A sub 1. And like Nelson said, how do we remember how to do geometric series? It's a pirate, R. So it's AR. So you can thank Nelson for that one on how to remember how to do this. And it's K. So we need to figure out what our formula is here. So what's our A sub 1? Well, our A sub 1 is 9. Our R, now I'm going to start speaking like a pirate. Thanks, Nelson. Our R is 1/3. Um, and we need to figure out our recursive formula. So what we're going to do here is we're just going to drag all of this here. How many terms do we go up to? 1, 2, 3, 4, 5, 6. There's 6 terms. So our n is 6. Our I'm super subconscious of when I say the word r. Our a sub 1 is 9 because that was our first term. And our r, so our r is 1/3, so we're going to plug in 1/3. And then it wants us to find the answer for this. So, oh my gosh. I hope you guys have a scientific calculator. If not, time to use ye old Google calculator. We can kind of make this a little easier if we think about it, because first one is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So just remember what geometric series is. We're always multiplying or dividing by the same number. I said multiplying, but multiplying by 1/3 is the same thing as dividing by 3. Our next answer is 1/3. Our next answer is, how many terms do we have? We have 6 terms. 1, 2, oh wait. 1, 2, 3, 4, 5, 6. Ah, they tricked me, guys. It's 5. We do have 6 terms, but we're stopping at 5 because this is our A sub 0, not A sub 1. So A sub 0 is what we start our formula with. It even says so somewhere over here. A sub 0, there it is. No, even then they talk about A sub 1. All right, so we start off with 9, and we're going to keep going. And we have to add all these together. 1, 2, 3, 4, 5, because we're multiplying by 1/3, plus this. All right, so now we can use ye old Google to make this easier. So we have 9 plus 9. There we go. 9 plus 3 plus 1 plus 1/3 plus 1/9 plus 1/27. And we get 13.48. Well, guess what? If you've been using a calculator, that's not going to help you out too much, right? But I didn't trick you guys. Here's what you do. So if you're ever like stuck on the test, I've let you guys use calculator, so it's fine. So we're just going to write this down somewhere. 13.48. And what I'm going to do to make this easier is I'm going to try these 2 points out. 364 divided by 27. Let's try this out. 364 divided by 27. Look, it's the same answer. So that's how you can answer a question using a calculator. You're going to solve it using the calculator normally. You're going to do some work on your own. And then you add them all up with Google, write that number down somewhere, and test your fractions out. Fractions are just division, so just divide them out. Does that make sense on how to do this one, guys? Everyone good? Anyone asleep? All right, cool. All right, so let's move on here. Sigma notation can be a very effective way of doing the series. So that's just saying like, hey, just use this formula. It's really cool. So now, I really recommend looking at these. I just don't want to go through all of them and repeat it because you guys are listening to me while you're going to listen to someone else explaining stuff that I'm already explaining. But here you have that little series like Nelson was saying, R, going on forever. And we're going to keep going on. I think they eventually tell you how to find the formula. They do. So here's our formula for finding a geometric series. We're going to use this formula from this. So when we're finding this out, our A is our starting point, our R is our common ratio, and N is the number of terms. This, I believe, only works when we start off with A sub 0. All right, so let's get going. So here's our formula. You can watch the video on how they figured out how to get this formula. So let's say we're trying to figure this out. Well, in order to figure this out, we have to put our number of terms. Our number of terms is not 49. It's actually 50, because remember, if we start at 0, we have to count 0 as one of those terms. So we're always one ahead. 0 is our first term, 1 is our second term, 2 is our third term. So we're always one behind. So by the time we get to 49, it's 50. And we plug it in here. I'll show you guys how to use the Google calculator to figure this out. It does involve using a pen and pencil, but for the most part, you can use a calculator. All right, let's get into this right now. All right, so they want us to figure out a sequence. All right, well, guess what? Here we're going to have to do some work. So it figures our last slide has the most amount of work. So first thing that I noticed, what is my A sub 0? My A sub 0 is equal to 2. What's my R? Well, my R is what I'm multiplying by. Well, it keeps being multiplied by 2, but it keeps changing signs. So it's negative 2 because it keeps changing signs. I keep multiplying by negative 2. All right. So I know that now. And we're going to keep going until something happens. We're going to do this weird thing right here, and it's going to be equal to what our formula was, which was 2, negative 2 to the who knows what power, right? So in order to make this a little easier, what I'm going to do is I'm going to divide everything by 2. 2 to the n minus 1 power. Well, here's what I can do now. I can keep dividing by negative 2 until eventually I get a number, or I get down to 1. If I get down to 1, I divided too far. So what I'm going to do here is I can keep plugging in negative 2 until I get to this, and I'm going to keep track of it. So let's keep track of when we get to here. So I'm going to do negative 2. Oh, let me use the Google calculator. I'm going to do these little hash marks on the side. This is the easiest way to do it. If you guys find other ways to do it, let me know. I can share it with the class. -2 times -2. How many 2's did I use? Wait, what? -2 times -2. Okay. So far, I've used 2 2's. So I'm going to use this little hash mark, 2 2's. And I'm going to do times -2. So now I've used 3 2's times -2. There is an easy way to do this using logs, but you don't learn that until pre-calculus. So that's why I haven't used it yet. So now we're at 4 times times -2. I just realized we don't even have to do this. I'm so sorry, guys. It's asking which one's bigger and which one's smaller. I'm so sorry. Wait. Oh no, we do because we need to figure out what's that. What's the formula again? How many terms? We don't know how many terms there are. Well, one thing I can let you guys know is this is going to be the smallest. I didn't want to get into it too much, but what ends up happening is we would have done this 10 times. I just want to make sure we have time to just chat at the end of class. So that's why I kind of just went like, you know what, let's just go into the answers. The reason why this works is you would be multiplying -2 10 times, which lasts a while. I don't know why they're giving this to you. It's a little hard. It's above the level unless you're using logs. There's no fast way to do it. You just have to -2 times -2 times -2 and keep going. And then you would get that 10. So after you do that, then you can use the formula that they were given to us. So if we can finally use that formula, a sub 0, what was this? It was 1 minus r to the n, because there's 11 terms, over 1 minus r, 1 minus r. If you guys have trouble understanding the variables, just remember a sub 0, first term. R is our common ratio. It's what we're always multiplying by. And n is the number of terms. I believe they describe it in that sheet I told you guys to print out. They describe most of them. I think they don't describe n. N is the number of terms. Oh, n is the number of terms in sequence. It's there, just kind of weird. All right, and so once we use that formula, we can plug it in. We would get this. Then we would use the next formula to figure out this one, which they do right here. We get that and that. So our biggest number is this one, and then it gets smaller. This is the biggest one because our alligator wants to eat the biggest thing. Then this alligator is stuck in between these two, and it wants to eat this one. And this is the smallest. So it's going from largest to smallest. So that's what's happening here. Place this from greatest to least. So that's why it has greater than, greater than. So that's it for this one. I will